totally not late. Shh, 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 shh. I say I needed supper and all this other stuff, so and I couldn't eat while reading these aloud. Unlike, say, I was playing a video game, which I couldn't really do that either. But I mean, I could figure out a way. Alright, hey y'all, this is Ciarfox. Welcome to my stream, which is the science stream of the month. I have a few articles, and other fun stuff. So, let's go ahead and begin. Alright, NASA spacecraft spots dead robot on Mars space surface. Martian artifact. Mars is collecting artifacts. Without the large, powerful camera aboard NASA's Mars Reconnaissance Orbiter, which observes Martian terrain for the past evidence of water and how the red planet is changing, we might miss it. But the craft captured the space agency's defunct inside lander and surrounding the landing site, slowly being blanketed by desert dust. Can you spot it? You? The center. Can you spot NASA Insight? NASA asked on X, formerly Twitter. The retired lander is recently spotted by the Mars Reconnaissance Orbiter. By studying InSight's landing site over time, scientists can see how quickly dust accumulates, which helps estimate the age of other surface disturbances. Hey, Haru! The InSight lander's mission ended in December 2022 after 4 productive years of investigating the geologic activity on Mars. The NASA robot measured over 1,300 Mars quakes, including a monster trembler, proving further evidence that Mars isn't nearly geologically dead. It analyzed Mars' core and also beamed back daily weather reports. Yet unlike NASA's Perseverance and Curiosity rovers, which are nuclear-powered, the InSight lander ran on solar power. Martian dust had expectedly whittled down the power of the lander by blanketing its solar panels in a thick layer of sediment. Eventually, its batteries died. At the center of the image below is InSight, obviously. Look closely, you can see its 2 deployed circular solar panels sandwiched on the main body. I guess it's those 2. Yeah, it is. I guess that's a picture of it before. Other past Martian explorers also rest quietly on the red planet's global desert, including the Phoenix lander, Opportunity rover, and Ingenuity helicopter. NASA has spotted discarded landing gear and parachutes too. One day, perhaps, these relics of early Martian exploration will be protected, similar to national park sites today on Earth. For now, InSight collects dust on the flat equatorial plains of the Elysium Platinum. Platia? Blech. By the way, I tried to, instead of just have mostly space things tonight, I tried to round it out a bit. I tried. Alright, I read this one earlier when I was bored and waiting for the Palace of the Dead stuff. Hi, Lone Wolf! Yep, I was late tonight. I'm sorry. I needed supper. Rewatched. Yeah, absolutely. Were you even there, Haru? This doesn't count. NASA-funded Pulse Plasma rocket concept aims to send astronauts to Mars in 2 months. An innovative rocket system could revolutionize future deep space missions to Mars, reducing travel time to the red planet to just a few months. The goal of landing humans on Mars has presented a myriad of challenges, including the need to quickly transport large payloads to and from the distant planet, which, depending on the position of Earth and Mars... Hi Rose, how are you? It would take almost 2 years for a round trip using current propulsion technology. The Pulse Plasma rocket Wolf well, okay, Wolf, is that better? Pulse plasma rocket under development by the How Industries is a propulsion system designed to be far more efficient than current methods of deep space propulsion, enabling the trip between Earth and the Red Planet to be made in just 2 months. Specifically, the rocket will have a specific impulse, or ISP, a measure of how efficient an engine generates thrust. This technology could therefore enable astronauts and cargo to travel to and from Mars more efficiently and rapidly than existing spacecraft, according to a statement from NASA. Stemming from the pulsed fission-fusion concept, the PPR uses a fusion-based nuclear power system, which obtains energy from the controlled splitting of atoms to generate thrust for spacecraft propulsion. However, the PPR is smaller and simpler and more affordable than previous concepts. In addition to enabling further range missions, the PPR could support much heavier spacecraft, meaning additional shielding could be installed to reduce a crew's exposure to harmful high-energy particles called galactic cosmic rays, endured during long-duration spaceflight. The PPR enables a whole new era of space exploration, NASA officials say. The exceptional performance of the PPR, combined with high ISP and high thrust, holds the potential to revolutionize space exploration, the statement reads. The system's high efficiency allows for manned missions to Mars to be completed within a mere 2 months. The PPR concept is now moving into phase 2 of the NASA Innovative Advanced Concept Study, having completed phase 1, which focused on the neutronics of the propulsion system, designing the spacecraft, power system, and necessary subsystems, analyzing the magnetic nozzle capabilities, and determining the trajectories and benefits according to the statement. During phase 2, developers will build upon the assessments from phase 1 to optimize the engine design, perform proof of concept experiments, and design a spacecraft concept to better protect the crewed flights to Mars. Currently only visited by robotic explorers, the PPR could one day bring NASA closer to establishing a permanent base on Mars. Alright, Perseverance rover! Rock sample may contain the best evidence of possible ancient life. The lead scientist for NASA's Perseverance Mars rover is excited about the material that has been stored in the rover's sample tubes. Okay. Say that's restating the thing. Both dropped on the surface of Mars containing within the rover itself, while wheeling about within the G0 crater. Given the samples of Mars that Perseverance has collected so far, could one of these specimens be what the rover was sent to look for in the first place? Evidence of past microbial life on the Red Planet. The preliminary findings heightened the need for returning these Mars samples to Earth so that these prized collectibles from the Red Planet can be sent to laboratories for a more rigorous analysis. Caltech's Kenneth Farley, project scientist for NASA's Perseverance Mars rover program, briefed the Extraterrestrial Materials Analysis Group, XMAG, during a meeting held May 13th through 15th in Houston, Texas. Tagged the Lefroy Bay, Farley called the attention to the sample collected by Perseverance rover, found to have hydrated silica. Hydrated silica. Ugh, why is my mind working? Here on Earth, that material has the highest potential to preserve signs of ancient life. So, a lively question waiting to answer arises. Perhaps Lefroy Bay carries preserved signs of ancient life on Mars. sample collected as leaf orbe at the margin unit may have been deposited either in a lake or a groundwater system. Both are very important to understand the Mars habitability and habitation at Z0 crater. The leaf orbe sample and 2 other samples from the same unit, the margin unit, are aboard Perseverance. Farley told Space.com, the margin unit samples have an abundance of carbonate and silica, clearly indicating a dominant role for liquid water in their formation. But whether the water was surface water in a lake or river, or groundwater remains uncertain, Farley added. Either could constitute an ancient, greater than 3.4 billion years old, habitable Martian environment. These samples host phases that on Earth are very useful for establishing a paleo-environmental conditions, Farley noticed, and they can also preserve biosignatures. As such, these samples are uniquely important for return to Earth for further studies, and not totally, create a virus. Joking! Objective set in stone. Perseverance is just about to make a really fundamental transition in exploration of the environment that we've been working on. Farley explained in his briefing, one of the challenges we face is this is not a great terrain for driving a rover across. So far, the Mars machinery has traversed some 17 miles, or 27 kilometers, after it was lowered into the area by crane on February 18th, 2021. The robot's objective is set in stone, seek signs of ancient life, and collect samples of rocks and regolith for possible Earth return. But why was the 28-mile wide or 45-kilometer Z0 crater picked as the reconnoitering spot for the rover? Scientists believe the area was once flooded with water and was home to an ancient river delta. Anticipation is that the Z0 crater is quite literally spilling the beans about its on again and off again nature of the wet past of Mars. More than 3.5 billion years ago, the river channel spilled over the crater wall and created a lake. What's possible is that microbial life could have lived in Z0 during one or more of these wet periods. If true, evidence of leftovers from these little critters might be discovered in a lake bed or shoreline sediments. Rover challenges. As for the overall health of the Perseverance rover, Farley noted a couple issues. For one, the loss of wind sensors that are part of the Mars Environmental Dynamics Analyzer, MEDA, built by an international team led by Spain's Centro de Astrobiológica. We have largely lost the wind sensors. They are essentially not functioning anymore. Also, the spectroscopy parts of the robotic arm-mounted scanning habitable environments with Raman and luminescence for organics and chemicals. I swear they go out of the way to make sure it works well. Sherlock, for short, go out of the way to make sure that that it works together. Sherlock, for short, or challenge. That's due to a lens cover no longer working properly. However, there's preliminary work done suggesting scientists might be able to recover Sherlock's spectroscopy abilities. We'll know more about that in the coming months. Three Forks Depot. The rover was dispatched to Mars with 38 tubes that could be used for rock, regolith, and even atmospheric sampling, or about 2/3 of the way through the sample collection. The on-duty robot has sampled igneous rocks, mudstone, sandstone/pebble conglomerate, carbonate, silica, olivine, as well as topside Mars sand, and snagged a whiff of Martian atmosphere. Okay, you have to say it that way? Earlier in its trek of Mars, Perseverance dropped 10 sealed sample tubes to a depot location dubbed Three Forks in the Z0 crater. The intent is that a Mars sample return mission in the future would pick up the sample tubes for rocketing those bits and pieces of Mars to Earth. However, that joint NASA and European Space Agency undertaking is now going through a detailed relook due to a projected 11 billion price tag and an anticipated but not satisfactory time period to pull off such a complicated endeavor. Stay the course. Farley told the X-MAG group that rover's operators are working to qualify Perseverance to 55 miles or 90 kilometers of traverse, allowing it to make its way to enlivening landscape. There's obviously an enormous amount of uncertainty with what the MSR is going to be. We are waiting to hear how they are going to play a role in that on the Perseverance mission. But for now, we're going to stay the course. We're going to continue to behave essentially as we have so far, with a strong focus on sample collection. Now in the rover's travel itinerary is completing tasks in an area called Bright Angel. Then move up into the crater rim, where the rover can survey fundamentally different geography. In ascending the rim, we will expeditiously complete the sampling. The sooner we get the sampling done, the sooner we can all rest easy that we've done our job. What happens next for Perseverance is a to-be-announced status. Maybe we will return to the crater floor to rendezvous with MSR. Maybe we won't. It'll all depend on what actually happens with MSR. Alright, NASA spacecraft saw something incredible near Jupiter's red spot. I love that underneath there it says squint. I don't know. Sorry. This is not just another sublime image of the largest storm in the solar system. Jupiter's red spot. Look closer, look closer. Come on, you have to try harder than that. Get in there. Do you see it now? That's not a speck of dust. Yeah, time to make this really fun, yeah. That's not a speck of dust on Juno's spacecraft camera. Oh, thank you. They're trying to say this with a southern accent. Timing. Next time around, turn this off for when I do this. Hard enough time reading some of this stuff aloud. That's a moon orbiting its enormous mother planet in space. So I guess it's talking about that. The teeny tiny moon is Alma-Thea, and though it was caught zipping in front of the very ruddy eye of Jupiter's long-lived high-pressure zone, astronomers say this moon is in fact the reddest object in the solar system. Scientists think its hue is caused by the sulfur from the nearby Jovian moon Io, a world with active volcanoes. Okay, this is NASA's, I'm not gonna say the whole, I'm just gonna call it X. I don't care about what the other part is, the formally shit. Hi there, Mini Moon. Our Juno mission recently caught a glimpse of the relatively tiny moon, Althea, above Jupiter's cloud tops. If you're standing on Althea, you'll have a spectacular view of the giant Jupiter. Make a virtual visit here. Should we click on that? Southern Belle, sweetie. My accent is a real accent. I just taught myself because children can be cruel. Especially, I just basically taught myself not to have it. But this is Althea was discovered September 9th, 1892 by Edward Emerson Bernard. Kind of a... Oh, wait. It's actually fun. Yeah, Southern? Nah, my Southern comes from my grandmother from in Georgia. Oh wow. Why do we call that a moon instead of like an asteroid or something? Well, it's called a minor moon. Radius is 51.9 miles. It's terrestrial radius. This is Mercury, and God. That's no moon. Yeah. Hell, it's bigger than Phobos, and Phobos is the moon of Mars, and it's considered a major moon. I mean, I could understand compared to Io, considered it. I mean, I guess because there's no other moon that's that big going around Mars that it'd be. Anyway, hey, I heard you have ADHD. Who'd have thunk? Yeah, relevant. Yeah, probably. Images released this week were taken by as the spacecraft swooped about 165,000 miles above Jupiter's cloud in March during its 59th close flyby. Citizen scientist, I'm gonna slaughter this name, I'm so sorry. Gerald is processed the probe's raw camera data to enhance the clarity of the pictures. Juno has an instrument dubbed the Juno Cam that was designed not just to take great close-ups of Jupiter, but also to engage the public. The science team allows citizens to process the camera's images and polls the crowd for what to focus on next. Juno has been orbiting Jupiter for over 7 years. I guess they're talking about JunoCam, because Juno definitely, since it's a moon, has been orbiting far longer than that. The spacecraft is studying the origin and evolution of Jupiter, looking for its core, mapping its magnetic field, measuring water and ammonia in the atmosphere, watching for its auroras, and homing in on Jupiter's moons and dust rings. I guess this is a better picture of it. You can see it there and then right there. During its primary mission, the spacecraft collected data in the gas giant's atmosphere and interior. Among its discoveries was finding... Okay, alarm went off. Woo! Okay, yes, phone. But no, this is, yeah, plantation accent. No, my grandmother's from Georgia, and I spent summers over there, so... I appreciate, hun. So it was hard to kind of read this aloud with it. Goodness. Among its discovery was finding the planet's atmospheric weather layer extends way beyond its water clouds. After completing 35 orbits, the spacecraft transitioned to studying the entire system around Jupiter, including its rings and moons. The extended mission will continue for another year or so until the spacecraft dies. Juno will eventually burn up in the Jupiter's atmosphere as its trajectory erodes. The spacecraft is not at risk of crashing into and possibly contaminating Jupiter's moons, some of which may be habitable worlds. Ugh. Althea is just one of Jupiter's 95 official moons. First discovered by Edward Emerson Barnard in 1892. It's about 100 miles wide, I guess, since I clicked on the thing. And clumsily shaped like a potato because it lacks the mass to form into a more symmetrical sphere. Almost 25 years ago, scientists got to see this little moon up close with the help of NASA's Galileo spacecraft, which revealed a pell-mell world of hills, craters, hills, and valleys. Hey, Drunk Vulture, how are you? Amalthea is within the orbit of Io, the closest of Jupiter's 4 large moons, along with 3 other oddly shaped mini-moons, Metis, Adresti, and Thebe. It's so close to Jupiter, in fact, it only takes Amalthea half a day on Earth to circle its planet. This moon is a mysterious little place in the solar system. Scientists have discovered that it gives off more heat than it gets from the sun, perhaps as a result of Jupiter's magnetic... Hi, hun! Thank you so much for the follow, Jabberwock33. Hey, appreciate the raid! How are y'all doing? Wow, science. Yep. This is the monthly science stream. So what were y'all doing? A fox sent me? Ah, of course. A fox. Persona 3 Reloaded? How is that? Let's say I became obsessed with Persona 5 and then Strikers. I actually have all the... it was in a bundle, so it's not the reloaded version. Yeah, it's doing the bidding of the Master Fox. But yeah, every first Thursday of every month I collect a bunch of scientists. Yeah, I collect a bunch of scientists and like tie them up in my room and don't let them go until they tell me a whole bunch of science articles that I should post. Not really, please, no, Twitch, no, or YouTube, please, I'm joking. But yeah, I collect a bunch of science articles and then feature them, of course. Like I said, normally I play a variety of games. Right now I've had an obsession with Final Fantasy XIV. Yay for autism. And then Wednesdays I play with Haru Tan and we do Monster Hunter World. And normally Saturdays would be Stardew Valley Saturdays, but I've become too obsessed with Final Fantasy to actually, let go on that. So this Saturday will in fact be the new Genshin update, so... But yeah, I have everything space. I have some, like, science stuff. Well, all of it's science, but I mean biology kind of stuff. I have some archaeology stuff. So, we have a good mix tonight. Okay, this moon is a mysterious little place in the solar system. Scientists have discovered... Oh, and if you need to, get a drink, stretch, all the other fun stuff, I can understand it. I appreciate the raid so much, and we'll see if I can take care of your viewers. With my ADHD, who knows? This moon is a mysterious little place in the solar system. Scientists have discovered it gives off more heat than it gets from the sun. Plays RPGs. Nice. Say, the running joke with Fox is most of the people who he brings in or I raid out to all have played Digimon at least once. Scientists have discovered it gives off more heat than it gets from the sun, perhaps a result of Jupiter's magnetic fields stimulating the electric currents within its core, or the planet's gravity causing tidal stresses. Oh, it was fun. It was interesting to watch. I was just kind of worried that if I was gonna do that anytime soon. By the way, this is Emthea compared to a few other things. the moon we were talking about. I didn't want to watch too much because I didn't want to spoil myself when I do eventually get around to it. Strange noises from me? Yes, all the time. Hopefully it won't. Remember to put it back on when I turned it off, but I don't know if it listened to me about the ads, so sorry if it gets going. Alright, the James Webb Space Telescope may have solved a Puffy planet mystery. Puffy planet mystery, Puffy planet mystery, Puffy. Sorry. This world is also way hotter than expected. A surprisingly low reservoir of methane may explain how a planet around a nearby star grew weirdly puffy. Been well, thanks. Of course, babysitting puppies. Weirdly puffy, according to new observations from the James Webb Space Telescope. The findings show that planetary atmospheres can inflate to remarkable amounts without employing esoteric theories of planet formation, astronomers say. The Webb data tells us that planets like WASP 107b didn't have to form in some odd way with a super small core and a huge gassy envelope. Michael Line, extrasolar planetologist at Arizona State University, said in a statement. Instead, we can take something more like Neptune with lots of rock and not as much gas and just dial up the temperature and poof it up to look at the way it does. Discovered in 2017 by the Wide Angle Search for Planets, WASP, consortium, WASP 107b, located roughly 200 light years from the Earth in the constellation Virgo, is among the lightest of more than 5,000 exoplanets found this far. Despite being nearly as large as Jupiter, WASP 107b weighs just 12% of the gas giant's mass, equivalent to only 30 Earths. For context, one Jupiter mass is equal to about 318 Earth masses. This planet is so puffy, the team says, that its density can be likened to a microwave marshmallow. From previous observations of WASP 107b's size, mass, and age, astronomers suspected that the planet had a small rocky core enveloped by a rich reservoir of hydrogen and helium gases. However, such a scenario failed to fully explain the remarkably bloated orbit, which, despite the fact that it orbits a star at 1/7 the distance between Mercury and our Sun, it doesn't receive enough energy from the star to account for its cotton-like density. Alternatively, if the planet's core actually held more mass than expected, scientists say the atmosphere would have shrunk as the planet cooled over time, meaning it would have turned out smaller than what is observed. Now, using Webb's data... I know, right? Num 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 num. Except that this might kill us with the gas that's in it. Combined with previous observation from the Hubble Space Telescope, two independent teams of astronomers may have solved the puzzle. In short, they discovered that methane in the planet's atmosphere is 1/1000th of what you would expect for this world. Because methane is unstable at high temperatures, astronomers say, the surprisingly low amount is evidence that the gas deep within the planet is mixing vigorously with cooler layers higher up. David Singh of Johns Hopkins University in Maryland, who led one of the two new 2 new studies. Sorry, I turned off the ads, but it's still saying that we're gonna run an ad. I'm sorry. The fact that we have detected so little, even though we did detect other carbon-bearing molecules, tell us that the interior of the planet must be significantly hotter than we thought. The extra heat likely comes from the fact that WASP 107b zips around its star every 5.7 days in an orbit that is not a perfect circle, researchers say. The star's constant gravitational pull on WASP 107b, whose distance from its star keeps varying throughout, stretches and contracts the planet's profile, thereby heating it up. On Earth, a similar force caused by the moon causes high and low tides. The planet's hot core, combined with tidal heating from its star, is also changing the chemistry of the gases deep within the planet. Jafar Romskov, who is a graduate at Johns Hopkins and co-author of one of the 2 new studies, said in a statement from the university, "We think this heat is causing the chemistry of the gases to exchange, specifically destroying methane and making elevated amounts of carbon dioxide and carbon monoxide." In 2020, a team of astronomers, including Singh, detected helium in the atmosphere of WASP 107b, marking the discovery as the first time this gas was spotted on an exoplanet. The element, which is tentatively spotted on the world in 2018, before having its existence there confirmed 2 years later, was seen extended far out into space as a tenuous cloud. Because this planet's atmosphere is so far-flung, astronomers say ultraviolet radiation from WASP 107b's star is slowly stripping the world of its air, about 0.1% to 4% of atmospheric mass every billion years. To be more specific, which results in a comet-like tail trailing around the orb. Thanks to the planet's supremely puffy nature, astronomers can look about 50 times deeper into its atmosphere than they would for a world like Jupiter. Last year, for instance, the Webb observations of WASP 107b's atmosphere shows that it rains sand. This research is described in the 2 studies published Monday, May 20th in the Journal of Nature. Okay, this actually, the whole thing of 50 times deeper. When I used to work at a space museum, one of the things that they actually brought into orbit, I heard this from one of the retired scientists that would docent there, they'd bring up human cells, like cancer cells and all this other stuff. And the problem with researching stuff like cancer is it's very compacted in with each other, so you can't see as much because everything's like pushed together. But one of the things they noticed on the International Space Station, of course, is the same way that you like grow a few inches for a while because your spine, you know, what's the opposite of contracts? My mind's dying. But they found that also works in cells. So they've been able to see deeper into cancer cells than they ever have before because the cells would start to spread out. Expands, yeah. My mind's dying. Yep, it would expand. Because the plates between them. Plates? Yeah. I don't know why my mind was lost on that one, but yeah. They also are growing a lot of tomatoes up there. I don't remember why, other than the fact that they're trying to grow. Well, they also have lettuce and all this other stuff. I guess they're trying to different types of food. They also have them. The tomatoes are put under different types of lighting as well. Maybe, but the thing is, the problem is, once you get back to Earth, your bone density kind of is taken away. But like the guy who's the longest, who stayed in space actually kind of had to be helped carry off the thing because he was in kind of a lot of pain. Because it's your spine is reconstructing. I'm already forgetting the other words. But it's pushing back together again, so it's so much pain because your nerves aren't used to it. Constricting. Constricting! That word! So aliens would probably have to deal with that. Yeah. And the thing is, he lost those few inches after a few weeks, but it was still really painful. For him. So they'll need to work out that problem as well. Earth-sized planet found orbiting nearby star that will outlive the sun by 100 billion years. An Earth-sized planet discovered around a nearby star offers astronomers their first chance in it for exoplanetary geography. Astronomers have discovered an Earth-sized planet that is showered with so much radiation, its atmosphere eroded away long ago, leaving it bare. Life as we know it can't exist on this blistering world, but astronomers are interested in it for another reason. For the first time, they may be able to study the geography of a planet outside our solar system. The newfound... some of these names. Newfound exoplanet named Spectolus 3b. I will just call it that planet. Okay. 3b. That planet 3b is a rocky planet roughly 55 light years from Earth. It zips around its host star every 17 hours, but days and nights on the planet are endless. Astronomers suspect the planet is tidally locked to its star, like the moon is to Earth. A single day side always faces the star, while a night side is locked in eternal darkness. I just am too lazy at this point. Yeah, also, yeah. Well, no, the thing is, for some of them, they do it by quadrants and by all this other stuff, or what program was used to find them with. But also, some of the, like I said, the whole Sherlock thing of naming that spectrography thing for the Mars lander, well, rover, is kind of saying, let's get this, you know, anagram to work. It will make it fucking work. Well, I'll still add the 3B part. Usually 3B talks about, like, B, is the circling, like, the, planets that circle the object. Well, I mean, circle this, the sun or whatever the largest object is. Telescope observations show that frequent radiation from the exoplanet star. Yeah. A 7 billion year old red dwarf about the size of Jupiter roasts the planet to Venus-like temperatures. So any atmosphere the planet may have had easily escaped into space a long time ago and left behind an airless, sizzling ball of rock, astronomers reported in the new study published May 15th in the Journal of Nature Astronomy. Life as we know it could not emerge on the surface of the planet. Atmosphere, no. Because it could not sustain enough sustain large amounts of water in liquid form. Lead study author Michael Gillian, an astronomer at the University of Liège in Belgium, in Belgium told Science. Okay, it's still gonna do an ad. I am so sorry, y'all. It's a bare rock planet like Mercury. Although that planet 3b isn't friendly towards life, astronomers say it is close enough to Earth for the detailed follow-up studies of its chemical makeup, which would reveal whether the planet was ever geologically active. Okay. Observations already planned with the James Webb Space Telescope, for instance, will have to be confirmed. We'll be able to confirm if volcanoes erupt on a planet. That will reveal how rocky planets like that planet 3b form around faint, lightweight stars, and if some of them could be favorable to life despite being closer to their stars. The researchers searched intensively for planetary siblings of that planet 3b in the same star system, but could not find any, Gillian said. He noted those additional planets may exist, but are simply too small or too far out from their host star to be seen. A hot planet around a cool star. Gillian and his colleagues discovered that planet 3b using a network of 6 telescopes spread across Chile, the Canary Islands, and Mexico since 2011. Okay, here's the answer of why it's named that way. That network is called the Search for Planets Eclipsing Ultra Cool Stars. How the... that doesn't work. Oh, which shares its name with a Belgian spice shortbread traditionally given to children every December 6th for St. Nicholas Day. Okay. The project's main goal is to detect rocky planets orbiting ultra-cool dwarf stars. Oh, really? Whose tiny size makes it easier for telescopes to detect orbiting planets. In addition to being thousands of degrees cooler than the sun and hundreds of times dimmer, they burn through their fuel slowly and end up living far longer, around 100 billion years. The sun will be roughly 10 billion years old when it dies in about 4.5 billion years from now. Fun. They're expected to be the last stars still shining in the universe, said co-author Amaury Trudad, professor of exoplanetary pathology in the University of Birmingham in English, said in a statement. Their extra-long lifespans offer favorable windows for life to emerge on planets within their systems, the researcher says. However, their extreme faintness makes them difficult to study. To discover that planet 3b, the name of that project, Robotic Telescope in Mexico, observed the telltale dips in the host star's light continuously for 5 nights in 2021. The first hints of the orbiting newfound planet emerged then and were confirmed a year later, according to the study. If there's no atmosphere, there would be no blue skies or clouds. It would just be dark, like the surface of the moon. Study co-author Benjamin Rackham, a researcher at MIT, said in a separate statement from MIT, and the sun would be a big purplish red, spotted, and a flaring star that would be about 18 times as big as the sun looks to us in the sky. That planet 3b is the 9th of such planet found by the project. The team expects to detect many more in the coming years, Gillian says. Like the planets previously discovered by the project, including a family of 7 in the well-known TRAPPIST-1 system, some which are consistently potentially habitable. The newfound that planet 3b is an excellent target for the James Webb Space Telescope. With this world, we could basically start doing exoplanetary geography, study co-author Julian DeWitt, an assistant professor of planetary scientists at MIT, said in the MIT statement. How cool is that? All right, NASA Space Telescope finds Earth-sized exoplanet, a different one. That's not a bad place to hunt for life. Gliss 12b is tantalizing close and moderately worn, situated just 40 light years away around the red dwarf star. Um. All right. Discovered tantalizing. Let's repeating it. An exoplanet or exosolar planet, excuse me, or exoplanet named Gliese 12b. I mean, that sounds better. Orbits a cool red dwarf star just located about around 40 light years from the Earth in the constellation Pisces. The exoplanet, which the team found with NASA's Transiting Exoplanet Survey Satellite, or TESS. I swear, their way for some of these acronyms. It's estimated to have a width of around 1.1 times that of Earth, making it similar to our planet as well as Venus, which is often called our world's solar system twin. Gliese 12b orbits its star. Yep, see, it says 12b, so, and the star is named Gliese 12, so closely that its year lasts just 12.8 Earth days. However, because the red dwarf Gliese 12 is just around a quarter of the size of the sun, it's also much cooler than our star. This means even though Gliese 12b is at a distance from its red planet equivalent to just 7% of the distance between the sun and Earth, it's still in its planetary system's habitable zone, also known as the Goldilocks zone. The habitable zone is the region around the star that is neither too hot nor too cold for planets to host liquid water, a vital ingredient for life as we know it. Though importantly, the two teams behind the discovery of Gliese 12b can't say for sure if it has an atmosphere. Therefore, it remains unclear if the world could be habitable, but the researchers have some cautious optimism. The majority interesting things is that this planet that's really nearby, in fact, it's one of the closest transiting planets to Earth. University College of London scientist Larissa Paleanthorpe, who led the research with University of Southern Queensland astrophysicist Cesar Solika, told Space.com, it's either in the habitable zone of its star or it's right on the edge of it, so it could be habitable. If Earth and Venus had a child, scientists spotted Gliese 12b as it crossed or transited the face of its parent red dwarf star. That's how one of the ways that they always are figuring about planets and stuff is if it has an orbiting planet and it's big enough, or at least enough, cause the star to fade when it transitions over the front of the star by which we can see. The other way they do it is through mathematics. Well, they also make sure that it's correct also with mathematics, but it's kind of these these transits cause tiny dips in light that TESS is adept at spotting. Oh, good that it's explaining. Paleanthorpe added that when the team went into this project, they didn't know what the orbital period or the size of the planet would be for sure. To find it to be such a similar size to Earth was kind of a lovely surprise, she continued, so that it was really a nice thing to be able to nail down. But I think especially knowing that, in terms of habitability, it could lie between Earth and Venus is really exciting. Gliese 12b receives about 85% of the radiation that Venus gets from the sun, but thought to have a much cooler surface temperature of 107 degrees Fahrenheit. Yeah, or 42 degrees Celsius, compared to the Venus's, well, I mean, there's a big difference. Surface temperature of 867 degrees Fahrenheit, or 464 degrees Celsius. Though Earth and Venus are both in the sun's habitable zone, one can support life and has favorable atmosphere, while the other is an inhospitable hellscape with temperatures hot enough to melt lead. Study Gliese 12b could help us understand why this is the case. Gliese 12b could teach us a lot about how our own solar system has developed as well, Paleanthorpe said. The team will now investigate whether Gliese has an atmosphere, but early indications are that if it does, the atmosphere would be relatively thin. Perhaps surprisingly, however, the lack of a thick atmosphere is good news for the planet's habitability prospects. We know that some planets have very thick atmospheres of hydrogen that would cover the entire planet. This very thick gas layer is actually bad news for habitability, says Vincent van Edelen. Usually these planets are 2 or 3 times the size of Earth. Gliese 12b is actually the size of Earth, so it probably doesn't have this very thick atmosphere. It could either have no atmosphere, which would not be great for habitability, or it could have this sort of thin atmosphere, kind of like the Earth's. Still, even if Gliese 12b does not have an atmosphere, it could still be an important test for advancing the search for life elsewhere in the Milky Way. That's because, as a red dwarf, the star it orbits happens to be the most common form of star in our galaxy. Yet one we know relatively little about when it comes to red dwarf planetary systems. In the Milky Way, red dwarfs comprise the largest family of stars that are still fusing hydrogen to helium in their cores, a process that defines the so-called main sequence of lifetime of a star. It's estimated that 60% to 70% of the stars in our galaxies are red dwarfs, like Gliese 12, and of the 30 stars closest to the Earth, at least 20 are red dwarfs. It's interesting to know that about planets that are around the small stars, what they might be like, and whether such planets could have life, Van Edelen said. Officially known as a K-type or M-type stars, red dwarfs have between 7.5 and 50% of the mass of the Sun. This low mass relative to the Sun means that such stars burn at a lower temperature, reaching only 6,380 degrees Fahrenheit, or 3,500 degrees Celsius, compared to the 9,900 degrees Fahrenheit, the 5,500 degrees Celsius temperature of our star. For instance, Gliese 12 has a surface temperature of around 60% that of the Sun. This lower temperature means that the dimly shining red dwarfs can exist as main sequence stars for much longer than the moderately massive stars, like the Sun can. Though the Sun is expected to live for around 10 billion years, red dwarfs are predicted to have lifetimes tens or even hundreds of times this period. Sometimes that figure can extend to trillions of years. What this means is life would have more time to develop on planets orbiting red dwarfs than it would on planets around larger main sequence stars. But it isn't all good news for the prospects of life on red dwarf orbiting exoplanets. Though they are cooler than the Sun in their stellar adulthood, red dwarfs are believed to be much wilder than our Sun. This class of stars is believed to be highly magnetically active, blasting out frequent and powerful flares of high-energy light in the form of X-rays. These X-rays can violently strip the atmosphere of a planet close to a red dwarf. Additionally, recent research has suggested that even red dwarfs that remain placid for many years can suddenly erupt with superflares 100 to 1,000 times more powerful than the Sun's solar flares. These eruptions are more common in the youth of the stellar class, and is also capable of stripping atmospheres and blowing away liquid water, even in habitable zones. At the moment, though, both teams involved in the discovery of Gliese 12b think the red dwarf in orbit is relatively calm, which is good news for the exoplanet's chance of possessing an atmosphere. Red dwarf exoplanets are good test targets. The fact that red dwarfs are cooler than stars like the Sun, and thus their habitable zones are closer to the stars, actually makes detecting exoplanets around them a little easier for TESS and its transitive method of planet hunting. We have biases towards detecting planets that are close to their host stars, essentially, because they transit more often. When we find planets orbiting red dwarfs, because they're smaller stars, the dimming of the transit is bigger, Paleothorpe said. Because red dwarfs are slightly cooler, the inhabitable zone lies closer to the star than it would be for our kind of sun, which means we're more likely to detect planets in the habitable zone with TESS. The team will have to turn to other instruments than the than the test to investigate the planet further. They will also switch to a different method of exoplanet detection to better define the characteristic of Gliese 12b. One is called the radial velocity method, which utilizes the tiny wobbles of planets caused in the motion of their stars as they gravitationally tug on these stars. I think the next really is to nail down the mass of the planet. We are already actively doing that as part of the high accurately radio velocity planet searcher for the North Hemisphere. It's called HARPS, but they're getting. I love if you look at the capitalization. We're ignoring velocity, and we're ignoring the F and the T, and then the H in hemisphere to get HARPS North team, which is a radical velocity telescope. Then we've also got another proposal accepted to the European oh my fucking god. European Organization for Astronomical Research in the Southern Hemisphere, Espresso. Where do you get the S in that? It's European organization. Why? We're just putting letters together in... Which is another radical velocity telescope, and hopefully from the kind of radial velocity observations we can do this. Paleothorpe and Van Allen also hope to be granted time with the James Webb Space Telescope to further investigate the planet's atmosphere. This is possible because Gliese 12b transits the face of its star. Light passing through its atmosphere will carry the characteristic fingerprints of elements in the atmosphere. This process, called transmission spectroscopy, maybe someday I'll get that right, more than once, instead of having to slow down. Gliese 12b is the only one of the handful of temperate Earth-like worlds that is close enough to be examined in this way. The James Webb Space Telescope is currently conducting a similar investigation for 7 Earth-like planets in the TRAPPIST-1 system, located about 40 light years away. These planets resemble Gliese 12b, and not only are many of them in the habitable zone. I think this is the one right here that it's showing right up here, the TRAPPIST-1 system, B, C, D, E, F. Yep, it's done by letters, right? But not only are there many of them in the habitable zone of their star, but the star is also small, cool, red dwarf. I think the telescope, with the telescope, we will get at least some clues about the atmosphere of this planet, which would be, I think, the next most exciting thing to do now that it's been discovered, Van Allen said. When it comes to the possibility of Gliese 12b hosting life, the two scientists are extremely cautious. After all, it is early days for both our understanding of this world and the methods that would be capable of detecting signs of life in an exoplanet atmosphere, even one so relatively close as Gliese 12b. I think Gliese 12b will teach us a lot about life, but we can't say anything for certain. I think it's very exciting, and we should definitely look forward to more research coming out of Gliese 12b. It's not a bad place to start on a hunt for life. Two teams' research was published on Thursday, May 23rd. All right. Something we shouldn't be messing with, but we're about to mess with. Quantum time travel, the experiment to send a particle into the past. Time loops have long been the stuff of science fiction. Now, using the rules of quantum mechanics, we have a way to effectively transport a particle back in time. And here's how! Because we aren't ruining anything here. When Seth Lloyd first published his idea about quantum time loops, he hadn't considered all the consequences. For one thing, he hadn't anticipated the countless emails he would get from would-be time travelers asking for his help. If he could have his time over again, he jokes, he probably wouldn't have done it. Sadly, Lloyd, a physicist at the Massachusetts Institute of Technology, won't be revisiting years gone by. Spoiler alert, no one will go back in time during the course of this article, but particles? That's another matter. Theoretical routes to the past called time loops have long been hypothesized by physicians, but because they are plagued with impracticalities and paradoxes, they have been dismissed as impossible for just as long. But now Lloyd and other physicists have begun to show that in the quantum reality, these loops to the past are not only possible, but even experimentally feasible. In other words, we will soon effectively try and send a particle back in time and not destroy everything. Oh god, I didn't realize I had to bitchin'. I'm not subscribing. Never mind about that article then. I'm not paying for that. Butterfly, yeah. I mean, someday I might pay for it, but I mean, I'm not making enough from this to pay for it. Comet fragments light up the sky over Spain and Portugal like a movie. Lisbon, May 19th. A bright comet fragment lit up the skies over parts of Spain and Portugal late Saturday, according to the European Space Agency, with one Lisbon resident saying the dazzling display felt like a movie. Yeah, I know, right? That's how that works. But later, on Sunday morning, ESA shared on X a video capturing by its fireball camera what it described as a stunning meteor over the skies of western Spain of Caceres, near the Portuguese border. Let's have sound. So pretty. See it again. But later is said to appear to be a small piece of a comet and not a meteor, estimating it flew over Spain and Portugal at a speed of 45 kilometers. Power range. I know, right? Per second before burning up over the Atlantic. The likelihood of any meteorites being found is very low. In both countries, the video shot in several cities and towns went viral on social media, showing the object crossing the night sky at high speeds and illuminating it in bright tones of blue and green. The Spanish Calor Alto astronomical observation also said in a preliminary analysis by Alases Institute of Astrophysicists that the object had a cometary origin. During a concert in the Portuguese city of Barcelos, the object was filmed streaking across the sky as the singer performed. Lovely timing. Another video shows the skies of Portugal's second biggest city turning bright for a few seconds. Many contacted emergency service to report what happened. A spokesperson for the Spanish emergency service 112 in Madrid told Europe Press News Agency it had received several calls. Lisbon resident Bernardo Tabora, 31, told Reuters he was walking around the city with friends when the sky suddenly turned bright green. It almost looked like daylight, and we all looked back and saw it. It felt like a movie. We were all looking at each other and we were stunned. It was amazing. Let me pull up the analysis. And it's in a different language. Thank you, Google. Please, please, please. Translate it into English, please. Yay! Okay, I guess that's the... Because they said it landed in the ocean, so I guess it went this way. Last night, May 18th, at 10:46 p.m., A really big fireball crossed the skies of Spain and Portugal. This object has been registered with the detectors that the SMART project operates in Carlito observatories in Almira, La Hita, Toledo, Nevada, Sierra Nevada, La Sarga Grande, Silver, and Marsa in Tarragona. Two of the external cameras of the Carlo Alito observation in Almira were also able to follow this spectacular event. Following the preliminary analysis carried out by Professor Jose Maria Modelo, Instituto Astrofísica de Principal Investigator for— I am so sorry, dear Professor. I am sorry. SMART project had this object had a cometary origin, entering the atmosphere of about at the speed of 161,000 kilometers an hour. The initial altitude of the light part of the event was 122 kilometers, ending at an altitude of 54 kilometers. This is a different one, I think. Different view. Let me see. Yep, I could get it bigger. I could get it bigger! That's what she said. I mean, he said. That's what he said! Bad joke. Bad joke is bad! There, right there. That's so cool. It's in the corner, but true, she can say it too. Also true. Here's another one. There we go. So cool looking. Not a nerd. Nope, not a nerd. Alright. Something strange is happening with the Earth's magnetic field tail. It's called the magneto tail, of course. You may not know this, but Earth's magnetic field has a tail. As the sun's solar winds buffet the planet, it leaves behind a sort of long shadow that trails out in our planet's wake. Scientists call this the magnetic tail, appropriately, the magneto tail. Typically, the magneto tail is strewn with magnetic storms. But for the past several years, scientists have known of a mystery in the magneto's tail, a missing storm. They have found a signature of a storm, but no storm actually going on with it. NASA's Magnetospheric Multiscale (MMS) mission is now on the case. MMS consists of 4 satellites that all launched on the same Atlas V rocket in 2015. Since then, the quartet has been studying the Earth's magnetosphere. Atmosphere. The frontier of the region dominated by the planet's magnetic field. The magnetopause is constantly aflame with magnetic reconnections, which refer to when the lines that make up a magnetic field come together, break apart, then rejoin, creating brilliant flurries of heat and kinetic energy. These reconnections, if they happen in the Earth's atmosphere, can cause auroras. Scientists call these flurry substorms. In 2017, the MMS spotted the trademark magnetic reconnection of a substorm, but no actual substorm to go along with it. A substorm should come with violent electric currents and magnetic field fluctuation, but MMS spotted traces of neither. We have not looked at the movement of the magnetic field's lines on a global scale, so it could be that this unusual substorm is a very localized occurrence that MMS happened to observe. Andy Marshall, a postdoc at the Southwest Research Institute, in a statement, if not, it could reshape our understanding of the relationship between tail-side reconnection and substorms. So, for the next year, MMS will measure the magnetic reconnections in the Earth's real magnetic field, while scientists on the ground conduct simulations on the magnetic field to understand how it behaves. By comparing the two, scientists hope they can solve the mystery by better understanding precise relationship between the reconnection and the events they cause. It's possible that significant differences exist between the global magnetotail convection patterns for substorms and non-substorms in tail reconnection. Blech.